In programming, arrays are fundamental data structures used to store and organize multiple values under a single identifier. They provide an efficient way to manage collections of related data, enabling developers to access and manipulate elements using index positions. Arrays are particularly useful when dealing with large amounts of data that need to be processed or analyzed systematically. Unlike individual variables which hold single data values, an array groups multiple values together, all of the same data type, such as integers, strings, or floats. This organization simplifies code, reduces redundancy, and enhances readability when working with datasets. A one-dimensional array can be thought of as a simple list, where the elements are stored sequentially and accessed by their position or index. Indexing typically starts at 0, meaning the first element of the array is at index 0, the second at index 1, and so on. For example, an array storing the names of the days of the week might look like days equals Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. To access a specific day, such as Wednesday, the program would reference days. This approach allows for rapid retrieval and manipulation of data, as the program can directly access elements without having to search through the entire collection. One-dimensional arrays are particularly useful for scenarios such as storing scores, managing lists of items, or handling series of numerical or textual data. Operations on one-dimensional arrays include adding, removing, or updating elements, as well as iterating through the array to perform tasks on each element. For instance, a program might calculate the average of a series of test scores stored in an array by iterating through the array and summing the scores before dividing by the number of elements. These operations are often performed using loops, which simplify repetitive tasks and ensure efficiency. Two-dimensional arrays extend the concept of one-dimensional arrays by introducing a second dimension, creating a structure akin to a list of lists or a table. In a two-dimensional array, data is organized in rows and columns, with each element identified by two indices, one for the row and one for the column. This structure is particularly useful for representing data with inherent two-dimensional relationships, such as grids, matrices, or charts. Two-dimensional arrays are commonly used in applications like game boards, image processing, or data tables, where the data naturally aligns in rows and columns. Manipulating two-dimensional arrays involves similar operations as with one-dimensional arrays, but requires nested loops to access or modify elements. For instance, iterating through a two-dimensional array to print its contents would involve an outer loop to traverse the rows and an inner loop to traverse the columns within each row. This nested structure allows for detailed control and processing of multidimensional data, enabling developers to perform tasks such as calculating totals for rows or columns, applying transformations, or searching for specific values. Arrays, whether one-dimensional or two-dimensional, are invaluable for their ability to store and organize data efficiently. They simplify the management of related values, reduce the need for multiple variables, and provide the tools necessary for structured data manipulation. By leveraging the power of arrays, programmers can create robust and scalable solutions to a wide range of computational problems.